Michael Esfeld. He will talk about how to explain quantum non-locality on the basis of discernible particles.
Yeah,
Thank you.
Thank you, Olympia. Thank you for putting together this great workshop. Now, I tried to put everything from the workshop into the title, and we see what we get out of it. Now, I'm a philosopher, so I want to have an answer about the three questions. What is matter? What is space and time? What are the laws of nature? And how does matter and space and time, and so far as subject to certain laws, explain the observable phenomena? And what I want to do is to sketch a very general answer to these questions in terms of a minimalist ontology. So just bread and water, not a large breakfast as we had this morning. Bread and water, minimalism, and to show how this may help to shed light on the topic of this workshop, which was here on identity, indistinguishability, and non-locality and quantum physics, on the basis of admitting absolutely discernible particles which are structurally individuated. So the proposal is very simple, just two axioms. We have distance relations. There are distance relations, and these distance relations individuate simple objects. That means objects that don't have any internal essence structure what you have. And let's call these objects matter points. And these objects are permanent. That's the second axiom now, and the distance relations between them change. So that's the proposal. That is supposed to be an answer to the question what is a minimal set of entities that form a common ontological basis to accommodate our physics. So there's nothing about necessity in there. There's nothing about a priori in there, although I talk in a very much general way, and it's, of course, it's fallible. It's inspired by Feynman. I mean, you could have many other quotations, but here's one from Feynman I like from the beginning of the Feynman lectures, where he says that suppose that in some cataclysm all of scientific knowledge were to be destroyed and only one sentence is passed on to the next generations of creatures, what statement would contain the most information in the fewest words? I believe it is the atomic hypothesis, that all things are made of atoms, little particles that move around in perpetual motion, attracting each other when they are a little distance apart, but repelling or being squeezed into one another. In that one sentence, you will see there's an enormous amount of information about the world if just a little imagination and thinking are applied. So that's what we shall do in the next 40 minutes or so. Apply a little, perhaps more thinking, less imagination. Apply a little thinking of imagination. See where we get. So the claim is that the atomic hypothesis, if you think through it, if you cook it down to what really is necessary, is essential to give an account of the physics, comes down to these two axioms: matter points and change, matter points that are permanent, and change in the distances between them. Nothing more in the ontology, right? Just these two axioms. And then we shall go through how can we get to our physics. And what I want to do then, the first thing is pure philosophy, so justify these two axioms by some philosophical considerations, and then have a quick run how they help with quantum physics and how they can help with getting an ontology for quantum physics that sheds some lights on these topics, indistinguishability and non-locality. So parsimony is a philosophical virtue, and the reason is that when you describe an ontological commitment, you need to give a reason why you should be committed to something. So your commitment can come from common sense, from science, for intuitions, etc. But why should man endorse an ontological commitment to that entity? And if it is minimally, so no necessity here, again, about the issue is about minimal sufficiency. If it's part of what is minimal sufficient to deliver an ontology of the natural world, that is a very good argument described an ontological commitment. That's the positive claim. And the negative claim is that if you enrich the ontology, you won't get further. You won't get better explanations. You would just get additional burden, like if you eat too much breakfast, if you always eat this breakfast, then you gain in weight, etc., and this may not be healthy. So in the same way. Just stick to a minimal diet and then you won't have problems. So this implies, of course, that the mathematical structure of a physical theory, which is much more richer, is not the appropriate guide to ontology. It is about representation, not about ontology. When we want ontology, it's a good idea to start with, well, the world has a plurality of objects, right? It is not just one object. Even if you have, like Jonathan Chaffer, a priority monism, so Chaffer claims on the basis of quantum entanglement and other arguments that the whole universe is prior to its parts. Maybe, but nonetheless, you need an internal differentiation within the whole universe. And to get an internal differentiation, you need relations. So the first point is that you need you can come from the side, you have a plurality of single objects, or you have the whole universe. In any case, you need relations. You cannot have just Leibnizian monads unless you have God, and the monads are not related to each other. To have a universe, we need relations. And then the relations can do all that the further work. The relations can carry out this differentiation. That is to say, the relations can individuate the objects, right? So if we need relations anyway, employ them to individuate the objects, and then you get what Stephen French once called thin objects. That means objects, thick objects would be Aristotelian substances. They have a form, an internal essence, intrinsic properties. Thin objects have nothing of that. The thin objects, there's nothing more than standing in the relations that individuate them. Okay, so we get a structural individuation of objects, and this delivers already a first result, Desue. So we don't have to accept a numerical plurality of objects as primitive. We get them, that's the idea, we get them from the relations. The relations will do the work of individuating the objects, so we don't have to start with a numerical plurality. It's a certain number of quasi-individuals or non-individuals, or however you want to call them, as primitives. The relations do the work. Which relations? Well, first guess, go back to Descartes. Nature, the natural world is res extensa, extension and motion, so we get distance relations. We need, so, on which we need relations, on which horse are you going to put your money to run? If you want the natural world, better put it on something which gives you some extension, some speciality. So distance relations. Distance relations are irreflexive, symmetric, connects, meaning that any objects are connected by them. And since we are looking for trying to do with as meager a diet as possible, fulfilling the triangle inequality is the only metrical requirement I would like to impose. So no further metric requirement. It's a minimal speciality requirement. But we have to do some more, say, some more substantial commitment. If the game is to avoid numerical plurality as primitive, the relations have to be such that we get absolutely discernible objects. So anything else would not do to individuate. So we have to exclude entirely symmetrical worlds. So we have to pay a certain price. So if a model of a physical theory admits an entirely symmetrical world, that would be nothing which is admitted in this ontology. Because then, of course, the relations would not be able to individuate the objects.
English problem. What is the exact meaning of discernibility?
That there is something, the meaning of discernibility is that there is something which distinguishes each object in your theory from all the other objects, right? And your position in this room distinguishes you from all the other participants of the conference. Even if your views distinguish you, of course, as well.
So
when it comes to physics.
Space is given then.
No, spatial relations are given.
But
There's
if there are 3% symmetrical, then it doesn't work.
It doesn't work, exactly. So we have to exclude that they are symmetrical.
But you could have weak discernibility in that situation.
Yeah, but that weakness, but as a famous professor, Demis argued some 10 or 15 years ago, weak discernibility just means accepting numerical plurality as primitive, because weak discernibility just is another expression for the fact that you have a certain number of objects without there being anything that distinguishes these objects. They just stand in an irreflexive relation to symmetric. This is not sufficient for individuation, weak discernibility. That's what you argued. James argued this as well.
But
So
the assumption that the world must be not symmetric?
Yes.
Or if it's symmetric, then it will not be world? Or what?
yes. Yes, we throw it out. It's a surplus structure of the mathematics because the real world is not symmetric.
Okay,
No, otherwise we won't be there. The real world is not symmetric,
I'm
right?
sorry. I
So,
propose
yes,
to
of
let
course.
the
So you
questions
see,
and
Lev,
comments-
you're very, I mean, you have slept well and etc. You immediately see where the first, where a substantial, debatable commitment comes in. Yes, but if I want to do the relations, the work of the individuation, then I need then I need something, let this job talk out, and I need something which distinguishes each object from all the other ones. If the relation is to do this, the configuration of the objects can't be symmetrical. And there's a certain tension in OSR, ontic structural realism, between laying stress on symmetries as guide to the structures in the world and the structures individuating these objects. And I always like clear options, so throw out one and take the individuation aspect. The symmetries are therefore representing. They give us the world is not symmetrical, but using symmetries and theories, of course, gives you a great improvement in simplicity and only a little loss of information about the world. So for certain purposes, it can be useful to represent our world as being symmetrical, although it is not symmetrical. This is all very Leibnizian. So Leibniz did not believe in symmetrical worlds. So we get, in fact, Leibnizian relationalism. We have distance relations. They make up, Leibniz defined the space as the order of what coexists, so they make up space. We get change in these relations, and we get time as derived from change as the order of succession in these relations. So change may be directed, but there is no temporal notion, no metric of time presupposed, and in any case, in the distance relations, there's no direction. So this may be an illustration of a configuration. They are distinct, these objects, and then you get through change, a whole stack of these configurations, which is ordered, but there is no flow of time or so introduced in there. So, and this, now I would like to use now a term that Nino did not use yesterday in his talk, but the credit is to Nino and collaborators just for the term a primitive ontology, right? And then I use it in my way. So I give the credit to you for the term, but I deviate from the so primitive ontology, that means that, so this is ontology tout court. That means that these are the entities that, according to the theory, exist simply in the world. John Bell used the notion local beables or beables, so these are the beables, but they don't have to be local beables in the sense that there's no space presupposed and they don't have to sit at points of space. So if you have the view of a configuration space with a wave function field on it, then this would also be, on this wider notion, a primitive ontology. I only need the distinction between something which goes through that door, and that's the door through which everything goes that simply exists in the world, which is the ontological bedrock, so to speak. And then there comes another door where everything goes in, which is employed to represent how what simply exists in the world evolves, develops, changes. So everything else comes now in, and there I would like to use the notion of a dynamical structure, just to have a term to play with, to employ. So the dynamical structure of a given theory then are all those parameters that come in through their function, that are defined in the way of what they do for the things that you accept as primitive. So Newtonian mechanics, for instance, you accept particles as primitive in absolute space, but mass, as for instance Mach pointed out against Newton, is introduced for its functional role in the sense of the role the mass plays for the evolution of the particle configuration. The particles have masses, then they attract each other, and then you get gravitation. Okay? So it can't be that everything is introduced just in terms of its function, because the question is, its function for what? So there has to be something for, which is the basis on which you can then define all everything else in functional terms. Okay. So, and for the basis, I would have something. I would have a proposition for something that simply exists in the world, given our best physical theories. So ontology is not theory relative. I mean, of course, you get only to ontology through your theories, etc., and all your proposals you come up, all your conjectures, they may change once your theories change, etc., but you make a proposal for what there is in the world, okay? So the proposal for what there is in the world is that there are distances individuating simple, that is point-like, objects, and change in these distances. And everything else, so masses, charges, fields, a geometry of space and time, wave functions, and what have you, comes in terms of the role it plays for the evolution of the configuration of meta points, right? And this is well motivated in the sense that when you, I mean, this was the discussion we had the other day with Olympia. When you choose, did you have a free choice? What is the important thing? What is the basis for you? Well, you choose position, of course, because this gives you then everything you need to account for experiments, because all the experiments that we have is evidence of discrete objects and motion, distances that change, right? So there's a good reason to distinguish position. There's a good reason when you want to do this in a minimalist way, not to assume an absolute space, but just spatial relations, and then let this do all the rest of the work, right?
It's not so different than our stance.
Okay, then I'm happy. Good. Yeah. Yeah.
Includes velocity, or includes position and time, or just
No. Position and change, relative positions and change of these positions, right? Now we have a
change. What do you mean exactly by change?
Yet you see, now there's a certain distance. Well, here, this configuration. Now I change my distance relative to you. We're in the next configuration. That is the change. And now you need velocities when you want to account for the change, when you want to describe it. But you just have these guys, left and Olympia.
Or that's continuous?
I'm not committed to either one.
But you're presupposing absolute simultaneity.
Yes. I'm working with these configurations. I would not put it because I don't have time, but I presuppose a configuration of objects individuated by distances. And this means that I presuppose absolute. Well, I see where I get, right? Well, I won't talk about relativity. That would be, but yeah, we can do this, come back to this in the discussion, because I have to stick to something like 40 minutes, right?
Yes.
Yeah, so I can't discuss relativity now, but of course there's a
5 minutes and then 15 of the
yes.
discussion, so
Yeah. We shall go on, right?
Yeah.
So the idea is you distinguish between primitive ontology and dynamical structure. You do this exercise, what you want to put in the primitive ontology. We just did it. Here what you put in. Everything else goes in the dynamical structure. And then now comes in a further, at least here, Nino, you will part from me, right? Yeah. So it comes in a further claim that when you look for what is minimally sufficient to account for the world, there is no need to subscribe to an ontological commitment to the dynamical structure. So no ontological commitment to masses, charges, absolute space, geometry, wave functions, and so on. Why not? You can put this in terms of unionism. So union metaphysics in the philosophical debate, David Lewis, etc., is the idea that you have a mosaic of local matters of particular fact. And this mosaic is the supervenience basis. That is to say, it fixes, it determines all the rest. But all the rest does not imply an additional ontological commitment. It comes with, once you have all So my Union mosaic is the meta points individuated by distance relations and their change. Let this be the Union mosaic. So you don't have any properties in there. Hence, you don't have any categorical properties. You don't have the worries which quarrel about David Lewis's unionism, so you don't have quiddities, humanities, etc. You have natural relations, of course, distances, but these are the only natural relations, right? And then this, I like to call it superunionism, although there's some credit also, this came up in a discussion with Gordon Ballard on relationalism. So you go beyond the standard, and in analytic metaphysics, the standard union, which is struck with properties, etc., which did not take into account the lessons of structural realism, right? So you go beyond them, called it superunionism because it's more radical. The idea is that you treat the geometry and the physical parameters in the same way as the union treats the laws. So, of course, a mass is not a law, a wave function is not a law, a field is not a law, but it comes in, it performs the same function as a law. It comes in through the role that it plays in the laws. So in that sense, they use nomological, being the means to achieve a representation of the overall change in the distances that strikes the best balance between simple and informative. So imagine you had a God's eye point of view, so you would know all the change in the distance relations, you would know all the meta points that there are, all the change in their distances, and now you have the task to give a simple representation of it. With what physical theory would you come up? You would need, of course, further parameters, because nothing in a configuration like the one here contains any information, nothing in these distances contains any information about how they change. So just working with distances and their change won't give you a physical theory. It won't allow you to write down a law. It would just enable you to write down a whole catalog, a long list of the change that happens. Now, if you attach to these guy masses and charges and whatever, or give them a wave function, etc., then you may be able to write down a law which represents that change. But the law is derived from the change existing in the world and being a means of representing this. So no additional ontological commitment, right? And now you can, yes, we should come. I mean, what would this mean for classical mechanics? Very briefly. So you have certain particle motions. You had, I mean, all this has been done by many people. So there's, unfortunately, the paper where Nat Hall discusses classical mechanics is unpublished. The published one in this Oxford Handbook to something is too short, right? So the idea is you have certain patterns in the motion, the particle motion. You then have the Newtonian laws, and these laws figure parameters, or the electrodynamic laws such as mass and charge. And given the motion, given the overall motion, you can attribute these parameters to the particles in order to represent their change. But they are not properties of the particles. Of course, the propositions that describe mass and charge, etc., are true, but what makes them true is the particle motion, not the particle properties. So again, you get the commitment which you may find objectionable. The commitment then is that the particle species and the standard model, whatever the different, all these particles do, this is not extrinsic, and this is not intrinsic, but extrinsic, namely derived from the particle motion. So some particles are electrons because they move electron-wise, so to speak, right? The electron-wise pattern of motion comes first, and then comes the attribution of charge, mass, spin, and so on, and so forth, which allows you to enable to represent their motion, and by giving them the label electrons, protons, what have you, this makes it easier to represent the motion. Same about space and time. Nick Haggard, the paper in some 10 years ago, right? Nick argues that you can, I mean, for a philosopher, for an armchair, there's an armchair, great, okay? So for an armchair philosopher, this is a very comfortable position to be in. So I can sit in my armchair, accept Newtonian mechanics, but am not committed to developing an alternative physical theory to Newtonian mechanics, which is not an easy exercise and which Leibniz failed. Just by claiming that the geometry of absolute space, inertial frames, absolute accelerations, etc., is the means to represent the particle motion that goes on, the means to represent that motion in a manner that is as simple and as formative as possible. But of course, one can also do the effort. Nino sketched this out yesterday and can do it even for quantum mechanics in the Bamiyan framework to develop an alternative physical theory as Julian Barbour does. But you need, in any case, you need more than there is on my minimalist armchair diet. So Barbour needs angels to develop shapes, etc. So there's something more in it, but nothing which gives you absolute space. Okay, so to make the philosophical point, you don't have to do this, but of course it is good to see that physics can go on a relationalist basis, right? So just, I don't want to be, the point now is that, we'll get to this point in a minute, but the point would be already here that you would say, okay, by pursuing this ontology, you're committed to non-standard physical theories. So a relationalist theory of classical mechanics is a non-standard physical theory, all the merits it may have. But I would not be in a comfortable position as a philosopher, as simply by philosophical considerations. I would be committed to subscribe to alternative physical theories, although there are good reasons to pursue them. Okay, quantum mechanics. Nino gave all this. So this scheme works very well in quantum mechanics as well, and that's why I'm a Bohmian. But I mean, the argument for the Bohmian position is, of course, not that it works well with my parsimonious philosophical ontology, but it provides the best solution to the measurement problem. So it should be clear. The argument now, why we get into this, has nothing to do with a priori philosophical assumptions. But okay, there's an a priori assumption in that I'm so much an empiricist that I would not like to give up the view that there's a single world, that there are single measurement outcomes, right? And if I take this as my common sense premise or whatever, if I take this as my premise, then the argument is that the Bohmian theory gives me the best solution to the measurement problem. And I need a solution to the measurement problem. This seems clear from logic, okay? And if I adopt this theory for an argument which has nothing to do with these ontological conclusions, then I can now use it as illustration to make the scheme of just having particles with spatial relations to make it work. Okay, so in Bohmian mechanics, as Nino told you, have particles that always have a definite position in space, so they are localized, and they are individuals. They are absolutely discernible individuals on the Bohmian scheme. Although I'm not sure how you treat symmetrical configurations, but the idea is that they are individuals. If this position changes in a continuous way, you have velocities, trajectories, you have a law or some sort of a machine where you put in the particle configuration as input, and then there's a machinery by means of the wave function which yields you the change of the particle positions, the velocity as output, and this law is there in addition to the Schrödinger equation. If you ignore the initial configuration, etc., Nino explained this, you get to the quantum statistical mechanics in a quite natural way. And you can do the same for quantum field theory. Here I'm the more purist than Nino, so I'm more, I mean, I like more what's called the Dirac Bohmian model. So you have a finite number of particles, change of distance relations described by a deterministic law, no particle creation, no particle annihilation. So exactly the same ontology. And then the game is to define an equilibrium state of the Dirac, which can take the place, or which is the ontological interpretation of what is usually called a vacuum. And this equilibrium state, because the particles are in this equilibrium, they are not observable. And what you observe are excitations of these equilibrium state. And these excitations then are described in terms of the usual Fock space operators with particle creation and annihilation. And the idea is that, as in the Bohmian standard non-relativistic Bohmian case, you get from this ontology and the law to the usual statistical account. So you do exactly the same here. And the argument, of course, is exactly the same. The measurement problem is there in quantum field theory as well. And you can apply exactly the same therapy to solve it, have particles, because all your evidence is particles. These particles are there. Their configuration make up the observed objects, and you can do in a detail. So this has been done. I mean, this is not mainly involved is Dirk Deckert from Munich in the paper we wrote together, and with Andrea Aldofredi, who was a former student of Nino's. Then the game then is to define this equilibrium state and show how you get in a more or less in a natural way these Fock space operators, and we did it for quantum electrodynamics. But in principle, it can be extended to other interactions. So it's simply not true that there is no Bamiyan quantum, that this particle model and this Bamiyan approach does not, I mean, you can discuss it, but there are on the table concrete, precise proposals how to deal with quantum field theories for interactions with them, which of course don't go beyond the, I mean, you won't get more than the standard predictions, of course, but that's not the issue. The issue is to have an ontology for that. So whatever maybe to this, it works, okay? So a bit polemic, of course, you cannot do ontology from operators in quantum physics. So typical fallacies, right? You have the Heisenberg uncertainty relations. Some people may be inclined to affirm there are no particle trajectories. You have appearances and disappearances of particles in quantum field theory. May be inclined to affirm that there are no permanent particles. But this does not help you. You get nowhere by such inferences because you have the measurement problem. And to my mind, the standard for ontology in quantum physics is how you solve the measurement problem. And to solve this, you need some ontological, whatever your ontological commitments are, but you need an ontology. You have to tell, however you solve whatever in this standard way of setting it up, whichever position you give up, you will have to go beyond standard textbook quantum mechanics to an ontology from which you can then deduce the operator formalism, okay? And then it's debatable, but I think premise, definite measurement outcomes, etc. You get there's a good argument for the Bamiyan position. And then, of course, now to the wave function, I would apply, I mean, James put this very well in your first question to Nino last night, and whether you then get to a dualism of two spaces, etc. And this, of course, would be suicide, because then you would have a wave function existing in a configuration space, somehow interacting with particles in a real space, and one of them will do, of course. So, and as an empiricist, the particles will do. So the wave function just is a mean. It is not an instrumentalism because the wave function figures in the law. It's not an instrument to calculate. The wave function figures in the guiding equation, which is the law, but then you can adopt a Humean attitude with respect to the law, which means that the wave function supervenes on the particle history. Right? There are a number of papers, a number of people in recent years which have worked out this view. So the wave function comes in as the means to achieve the most simple and informative representation of the particle motion. And what there is in the world is the particle motion only. And this particle motion means relative motion, etc. So no commitment to absolute space in there. Okay. Some people may like to go further. So we throw masses, charges, forces, fields, wave function, etc. out of the ontology. Now, this means that you have to accept as primitive the particle motion. But you may want an answer, why do the particles move in the way they do? And masses, charges, forces, fields, wave function, etc. laws as primitive as in Maudlin are supposed to give you an answer to that question. But the problem with that answer is that you define them in terms of what they do for the particle motion. You introduce them through their causal, functional, or dynamical role for the particle motion. So it is circular. It is like the Molière caricature of the medical student who is asked the question why people fall asleep when they consume opium. Yes, because opium has a property which plays the role of making people fall asleep, right? So why is there gravitation? Because objects have the property which make them attract each other, etc. And of course, these are past parsimonious properties, but the scheme is the same. So I'm not a Humean in the sense that I'm concerned about necessary connection, etc. I'm just not, I used to defend these positions, etc., but I'm not sure, I don't see the explanatory gain in them. So there may be something in the world, I mean, there may be law, there may be something from God's point of view which makes the development of the world necessary. So then, I mean, there's Galen, Strawson's Hume, which is just an epistemic skeptic about us having access to necessary connection and makes no ontological claims. So then I would side with that. I'm agnostic about this. I just see that if I charge my ontology with all these things, I don't get an explanatory value. I just get artificial problems, such as the problem how a wave function in configuration space guides or makes move particles in physical space, etc. How, if you think of masses as intrinsic properties, how a mass being intrinsic to an object can make that object across space, action at a distance, attract other objects, etc. And the same argument applies if you make entanglement wave functions, add relations of entanglement, add structure, add commitment to structure beyond the spatial structure to your ontology. So you then have the question, why do these things move in a coordinated manner, etc. So my answer to the non-locality is also easy. The non-locality, in principle, is just what you would have expect whenever you have an ontology which structurally or holistically individuates its objects. If Lev moves with respect to me, or if I move with respect to Lev, then I change also my distance relations with respect to Hans. With respect to every, so if one particle in a configuration defined by distance relation changes its distance with respect to another particle, everything changes in the whole configuration. But of course, there's nothing, no action going on somewhere. There's just coordinated particle motion which you describe in terms of wave function, etc. So the holism is just what is to be expected whenever you have structurally individuated objects. Of course, this is no answer why there are these particular correlations in quantum physics. I don't have an answer to that, but no one has an answer to that. But there is at least no worry in such a view about some spooky action at a distance, as Einstein said, etc., because it is only about change of relative distances of particles. And of course, the way in which two particles change their distance, this depends on, or this has effects on how all the distances change. And then, of course, you need a method. Nino sketched this out to get locality, so to get just local action, because otherwise you could not do physics. So Einstein is right. But it's the same. Think about the philosophers, about Davidson on semantic holism. When you change one of your beliefs, you change all your beliefs, and then you need some method to make this local, as Fodor argued against. So it's the same game whenever you go for entities that are structurally individuated. Then you get a non-locality. But there's no reason to worry about it. There's nothing as, for instance, in the collapse interpretation, where when you apply the collapse interpretation to matter in space and time, then somehow when the wave function collapses on configuration space, somehow some matter is delocated in space, etc. Nothing like this happens here in the Bohm theory. That's why it illustrates well this view. You just have correlated particle motion, and the correlation is just to be expected when the particles are holistically individuated. Okay, so I should come to an end. And so the question, the pertinent question is, what's your ontology? For what are you going to put your hand in the fire? What is your ontological commitment? That should be. You cannot read your ontological commitment off from a scientific theory. It should be as parsimonious as possible, but it should be sufficient to account for the evidence that you have. Then the second question is, what is the dynamical structure? How do both explain the evidence, what you need in? And the proposal, right, from Democritus to Feynman is that you have point particles. They are individuated through spatial relations, change of these spatial relations. Everything else comes in terms of its role for this change. And now the ontology, everything is very easy because this primitive ontology, the ontology remains the same for all physics from Democritus on. What changes is the dynamical structure. What changes is our conjecture how to best represent the actual particle motion. So I take this to be a robust scientific realism and a robust physicalism because it's very clear to what you are committed. And this remains the same unless something funny happens in quantum gravity. I don't know. Thank you.
James first. Okay.
Thank you. I'm sorry if you said this and I missed it. You mentioned Descartes. And Descartes didn't have a distinction between matter and space. But you do, because you have point particles and then you have empty space.
Yes.
Are the point particles impenetrable? That's
yes.
Yes, okay.
Because, I mean, the distance relations distinguishes them, so if there were no distance, there would be no distinction. I mean, I may just mention Descartes because the point was an extension. I did not want to interpret Descartes literally.
So just to get the picture right, so your point particles, the only properties they have are
the
relative
distance.
position
Yes.
and impenetrability.
No. Relative position.
And impenetrability.
No,
they can't,
relative, but the stipulation...
you can't have two particles at a point.
No,
So
because the stipulation is that the distance individuates the particles, right?
Yeah.
Distance can't be zero.
Yes.
That's my point.
It's a stipulation,
right.
by stipulation.
By stipulation, yeah.
Yeah.
And
then you get out the impenetrability,
So
but you have to make the stipulation.
they don't have mass, they don't have
Yes.
anything else.
Yes.
Okay. Yeah, I just wanted to be clear about what the picture was.
Yes, yes.
Nothing comes from here, first nothing, and then...
But of course, all the statements that describe mass or so are true. The truth maker. So there's nothing, there's no instrumentalism or fictionalism, etc. Of course, they are literally true. And the issue is what, in my ontological commitment, is the truth maker for all these statements. So if you just put it this way, there's no mass or so, that I'm not mad. I mean, I don't want to... Yeah. Yes, yes, and the wave function supervenes and the particle positions and their changes the truth maker for all that story. So that the story is literally true, but the ontology is not committed to any funny things and problems. Okay, thank you.
So this question is motivated by a lifelong commitment to what Wigner called the unreasonable effectiveness of mathematics in the natural sciences, right? And so you give us a minimal ontology or a minimal primitive, minimal set of primitives. I guess, first off, I just want to say, let me ask two questions. Mm-hmm. One is a real question, one's a meta question. The meta question is why are some things in blue in your talk? Because whatever was in blue, I disagreed with, right?
Oh, okay. So there was a correlation between us that I randomly chose colors, but
I mean, it's not 100% correlation, but whatever's in blue, I disagreed with. So my question is then, so we have the unreasonable effectiveness of mathematics and the natural sciences. Yeah. So then is it implicit in what you're saying then? I mean, you know, you describe certain problems sort of as fake problems, right? Like, or sort of, these are problems of the representation, not problems of the ontology. So do we consider the foundations of mathematics and logic as fake problems in this sense? Or are they hidden in your primitive structures, that there is a mathematical structure, that there are rules, that there's some sort of axioms or completeness, or Zermelo-Frankel, whatever it is. So where is math in this?
Math, to my mind, is on the side of representation. But I don't have an argument. You know, this was not about the philosophy of mathematics, or mathematical objects. So my inclination would be to be a nominalist.
Physics without mathematics.
Yes, of course. But I mean, this is the human mind, and I mean, I did not say anything about human mind, etc. And I don't mean this. I mean, that would be another issue whether, and the way a functional definition in which you introduce masses, charges, etc., you could also introduce mental properties that way. It's not, not at all the issue here. So the masses, but so the mass is a means of representation. What now? And of course, you look for an efficient means of representation, and we may be quite successful in that. So why is this a problem, or what is?
I mean, so I just know that I could not derive the math I need from distance of particles.
Of course not. Yes,
Right?
I mean, at some stage, Olympia, and I looked at the clock. Of course not. But I think I said this. Of course, you can't.
Right.
I mean, if I just give you what I had on the slide, the stack of these configurations, you cannot derive anything. So you have to make a guess how to get to, what's this? Somewhere here. Right, of course. If I just give you this, you cannot derive any mass, etc. So you have to make a conjecture. Now, how to represent this, how to put this into geometrical space, what dynamics put on it, so that I get, supposing I have some information about these relative positions.
What about logic?
A good representation. Yes, it's the same.
Logic is the same.
It's the same. Logic, mathematics is the same. I mean, I'm not, this would be, again, another issue to defend, but just flag this, the Quinian view on two dogmas on confirmation holism. That comes all in mass is just a more abstract manner of representing the world than saying there's a bottle of water here, but it's in the representation bag. And of course, then there's an issue to be discussed about the ontology of mathematics, etc. Yeah.
I would like to make clear the idea what ontology is and what scientific theory is,
yes,
because I feel a little confused. For me, scientific physical theory is supposed to tell the following: describe me what is now, tell me what will be in the future, or maybe tell me what was in the past too. And the ontology is what I need to describe now to know what will be in the future and what was in the past. This is, for me, the idea of ontology. You kind of present the complete block universe, everything which happened. Yeah. It's history. It's not, for me, scientific. It's description. I need theory. Theory is supposed to tell me what will happen, maybe also what was. This is, for me, a theory. Description is not a theory. I can describe all kinds of description. I need description. And ontology, for me, it's a minimal entity which will allow me to know what will be in the future. Now, if I know position of all, I understand the good example of your theory is Bamiyan theory. If I know Bamiyan position of every particle now, I don't know what will be in the future. Yes. I need to know the wave function. Yes. So the Bamiyan position cannot be the whole ontology. The wave function is part of it. No. If you tell me the Bamiyan position all over the time, then I can find that the only wave function is such and such. But it's not interesting, because I want to know now, in the ontology, it's for particular time to know what will be in the future. Not the whole history. The whole history, it will be, there are conferences on histories, and then maybe they describe block universe, everything. They don't describe physical laws. Physical law, as I understand, supposed to give me description now, tell me what will be later, deterministically, probabilistically, or any other way. Anyway, what the ontology, it's a description now. And this is the only thing which you allowed now, it seems that you start with the whole picture, so there is nothing to discuss. There is no, okay, I want to know what will happen, and you start with what will happen.
I mean, there is an issue about. I mean, there's an issue about the metaphysics of laws. So, are the laws primitives or are they derived from something? If you want the laws as primitives, you have to answer questions such as how the law plus the initial configuration can bring about the future of that configuration. And these questions may not have an obvious answer. And the issue is not, of course, if I give you a present configuration, and what you want now a law for that configuration so that you can derive that and that one. Of course, yes. So what? What is the ontology now?
This
the
is
ontology
now.
is not, of course, the fact is that if I give you just this as the ontology, you cannot derive anything.
No,
the fact
it's
is also
slow.
that you consider if I give you this, the whole stack, then, but that's how science proceeds. You get a certain amount of data, and now you make a conjecture of what a law for these data may be. And then it's a metaphysical issue whether you think that given all the data, the law is fixed, so that the law is not an additional commitment, or whether you want to have the law as something that somehow governs the world, guides these particles in a literal sense, makes them move. But that is a philosophical debate. And if you want the law to have this, you get some troubles, such as accounting for how
This is science, no? Science is
it's not
different.
settled by science, not at all.
Physics not supposed to tell me what will happen? People
Yes, of course,
Yes,
of
so
course.
this
But so what?
Newton
Yes,
and quantum mechanics
physics,
is a theory.
but by looking at the physics and by looking at the fact that putting initial condition into a law, your ontology is not settled. Sorry, the answer what a law is and what the metaphysics of laws is not answered that way.
I'm not sure. Standard quantum mechanics. Schrödinger equation is a
Yes,
law.
yes.
Then we have ontology, wave function. Wave function is my ontology, and I have to know what is
I
wave
know
function
this,
now.
and I take this proposal seriously, right? But I don't think that it follows simply from the fact that the wave function figures in the Schrödinger equation that the ontology is the wave function.
You can have ontology, wave function plus Bamiyan position.
Yes.
Or you have Newtonian mechanics, you have particles and fields.
Yes.
Without fields, you cannot get it. You cannot get classical physics. So, you didn't mention
But I
that.
don't need an
No
ontological
fields,
commitment
yeah,
to
in the beginning of the universe, there were no particles, only radiation. So it's not clear how you have...
No. There were only particles. I can do all the physics with that. Of course, you can disagree, but it is not that. I mean, this is I said at the beginning, I'm a philosopher, sorry, right? So I appreciate your position, but I want to have, for my ontological commitments, an argument. And
but
the simple
exactly
fact that wave functions figure in
No, but exactly, as a philosopher, I want to understand what scientific theory is. Physicists are not maybe so good in it.
Scientific theory
I maybe as a physicist thought that a scientific theory, physics in principle, have to give me the answer. Describe what is now, give me the laws, to tell me what will be in the future.
Yes.
This is a definition of a theory. And what you do, it's not this.
Of course it is. What's the
No,
problem?
you start
I want
with
two
the
things.
closed future.
I want you to in German you would say Farbe bekennen.
What?
How do you say Farbe bekennen, which means put your commitments on the table. I want you to tell me what there is in the world simply, okay? And then the theory will tell you what it is. So I want you to give me this chop talk, your primitive ontology and your dynamical structure.
Let us see.
This is the theory.
A little
Tells you what there is in the world and you say.
from Pino Kant.
I think we are not understanding each other. Michael, on the level of physics, agree with you completely.
Yes, of course.
So there is no contradiction between what Michael is saying and what you are saying as far as physics is concerned. The worry of Michael is metaphysical, and the metaphysical nature of laws, on which he has a view. I mean, there are other possible views,
Yes.
but he's defending a certain view in a coherent way. So there is this gap. I think you don't understand each other. Because he talks about physics and you talk about metaphysics.
But we should understand
I feel
one
like they
another. We
do
are here for
understand
that,
each
yeah.
other. I think that, I mean, I agree with Lev. I mean, he's just not a human. I mean, he just doesn't think that this is explanatory at all, this kind of ontology.
But whether
And
you're a
that's-
human or
and
not
that's
is
right.
not settled by the fact of certain parameters figuring in certain physical equations. That was the only point I want to make. Whether you're human or not is an argument in the metaphysics of laws, not in the physics.
But what he was saying originally. So I just wanted to say there was just like false advertising at the end. On your very last slide, it says this is robust physicalism.
Yes.
This isn't physicalism at all. I mean, physics says that physics doesn't say, I mean, what physics? What physics says that all there are particles and
Sorry.
spatial relations?
Yes. That's the ontology of physics. And that's a robust physicalism because
But
the answer
that's
is what is
not
the
physical. That's never, I mean, I don't know what you mean by physicalism. Like, physicalism is, I pay attention to physics, but then I just sit in the armchair and come up with whatever I want, and then try to get whatever ontology I wanted from the armchair to kind of somehow magically be consistent with the physics. I mean, that's not physicalism. I mean, physicalism is I have my physics and then I let that guide my ontology. But
nice,
you start the project from physics. You don't start the ontological project from the armchair. Okay, so I mean, I'll just ask it.
Just tell me what is wrong with the proposal.
I'm not telling, but that's not. I just said I'm not saying what's wrong with the proposal.
So there's nothing wrong with the proposal.
No, I mean I'm not. I don't have your. I don't have your. Okay. Well, James can ask.
No. There's an issue about. Sorry, a bit polemically.
I'm asking my question.
Yeah,
now,
and my question was.
I'm asking my. No. Let me ask my question.
Yeah, sorry.
Okay. Because I just said this is false advertising. Because as far as I understand what physicalism is, physicalism involves starting the ontological project from physics, not starting it from the armchair. So if you want to say this is robust physicalism, please tell me what that means. I don't know what that means.
Yes, it means that you answered it. You cannot deduce the ontology from the physics. The question I wanted to answer is, what is a minimal set of entities to which we have to be committed in order to make sense of our physics? And I answered that question. And now, of course, the advertising which may not be justified is which I cannot justify in 40 minutes, is that answer holds for the whole of physics.
So for you, robust physicalism means coming up with the minimal ontology that's required to support physics?
Yes. That's one, but it's a way of physicalism.
That's not what's usually meant by physicalism. You can say whatever you want.
It's an ontology for physics.
The last question, Dennis.
So what I understood is that the main motivation for this project is not physicalism, but more empiricism.
Yes, that you get a physical... that it is.
And so this idea of that there are only moving particles, but point particles, that derives from what we see and experience. But we never see point particles. It seems an enormous idealization and very far from empiricism.
Yes, no, but position measure, as Bell argued, and I think correctly argued, is that position measurements are distinguished. Of course, these particles are theoretical entities, right? So there's the issue is on minimal sufficiency. And of course, you make, I mean, that's where I'm a Popperian in that sense. You make a conjecture. You don't infer your ontology from the physics. That's fishy. Sorry. You'd have to. No, that's not physicalism. That's bad philosophy. Sorry. You cannot infer from the formalism.
But I agree that it's not physicalism, these points, and it's not empiricism either.
It gives you a proposal. It gives you a proposal for what the content of physicalism could be. And this proposal is the...
Okay. Last comment. This is for the physicists in the room. So Michael at several points said, as a philosopher, I do this and this. I just want everyone to know that there are philosophers, including Alyssa and James and me, who think that the proper approach to philosophy of physics is to start with the physics and try to understand what it's telling us about the world.
Yes.
And Michael takes the opposite approach to start from an ontology and try to fit the physics into it. We don't all do that.
Sorry, no, but then I should have one sentence to say, I mean, I like putting my cards on the table, right? But I did not get to this from Andre, so I like to start with the cards on the table, what we are talking about it. But of course, this comes from the physics, but not in a way of logically, you cannot infer from the physics, but you make a proposal, let the physics be the guide to your ontology. Where do you get particles in motion? And then you have your ontology, and then you do the rest of it. But you can debate whether this is the best ontology, but I object to being outcasted here as not doing proper philosophy and etc. No. I mean, the proposal may be wrong, it is debatable, but it is a proposal, I mean, it is within the club. It is not There's no reason to exclude it. It is, you look, what is the ontology of physics? Yes, of course, it's matter and motion.
Okay.
His sentence was, oh, physical theories do not carry ontology on their sleeves.
Yeah.
And this is done when he was criticizing, let's say, the Quine way of putting ontology in physics by
Yeah.
designers.
Yeah,
then he was explaining, yeah, that doesn't work, but that is the moral is that physical theory do not carry their ontology on their sleeve. Yeah. And I think the reflection of Batman is a sort of, it's not just Michael, I mean, I think it's very common, this view, among the people worrying about metaphysics. I should not be defending metaphysics.
Yeah, but thank you for defending it better than I can do it. Yeah.
Nino, I feel like what you do, I feel like the way you justify the particle ontology of Bamiyan mechanics is different, and it's more like physicalism than where, and I'm not saying you're an outcast. I'm just saying you're starting from a different place than we're starting. That's all I'm saying. It's just a different, but what you do, I don't know, the way I interpret what you do, and maybe this is wrong, but the way I interpret what you do is you say, look, quantum mechanics was always about matter and motion. And so yes, they use the psi, the wave function, but the wave function is the physics. The physics was the physics of matter in space-time, and that if you properly understand the role of the wave function isn't about it isn't describing the matter. It's describing how the matter behaves, and that's still physicalism because you're still like, look, this is the role of these things, these variables, these representations in physics. But Michael, the way I understand where you're starting is you're starting with what is the simplest. You're starting from parsimony, and you're very explicit about that. What's the simplest ontology I could have? The simplest ontology I could have is particles. You're not arguing that we should start with points.
I could do the talk. Yes, I should have done the talk the other way. Yeah, but Elisa, this is just the manner I write for the paper. I do the talk the other way around. This is nothing about substance.
It's not a criticism. It's
but
just saying.
No, I mean, it's just you criticize the way I did the talk, but I could have done it the other way around. So you start with the physics, and then you ask, is the ontological commitment to all masses, fields, etc., should you have an ontological commitment to that? And then we have a conversation about that, and then I give you a particular answer. This is just how to set up the talk, so I should have started from slide 20 to go to slide 1 and not the other way around.
Thank you.
Thank you.
Very much.
Thank you.